Hello and welcome to Scottish Maths. In our video today we'll be looking at irrational numbers. But before we dive into that, it makes sense to talk about what a rational number is. So a rational number is a number that can be expressed as a ratio of two integers, or in other words as a simple fraction. So take the number 3, for example. This can be expressed as 3 over 1, or 6 over 2. So all of these are just ways of expressing the same number 3 as a simple fraction. So this is rational. Another example, say the number minus 9 can be expressed as minus 9 over 1, or minus 18 over 2, or even 18 over minus 2. Again, this is just expressing the same number, minus 9, as a simple fraction. So let's take 0.25. This can be expressed as 25 over 100, or 1 over 4, or a quarter. Again, all of these can be expressed as a simple fraction, so they must be rational numbers. Now, let's have a look at irrational numbers. So an irrational number is simply the opposite of a rational number. It's one that can't be expressed as a simple fraction. So let's just quickly cover the idea of non-terminating and non-repeating. So a number whose decimal point goes on and on forever is called non-terminating. So for example, 0.123, 123, 123, 123, and so on and so forth is non-terminating. It goes on and on forever. Then there's a number whose decimal point never repeats. So this is called non-repeating. So 0.45678910111121314, non-repeating. So when a number has a decimal that is non-repeating and non-terminating, then that number can be considered an irrational number. So some really famous examples of this being pi. So that's 3.141592653 and so on. It is non-repeating and it never terminates. It is an irrational number. Then there's phi, the golden ratio, 1.61803339, and so on and so on. It is non-repeating and non-terminating. It is irrational. The square root of 2, 1.414213562, and so on. That is a non-terminating and non-repeating number. It is irrational. In fact, if we take the square root of any non-perfect square, so the square root of 3, the square root of 5, the square root of 7, the square root of 11, and so on, they are also irrational numbers. I'll just scrub the board here, and an important point to make is that sometimes you can have a number that is non-terminating, but it does repeat. These are considered rational numbers. So a really simple example of this is 0.666 recurring or repeating, which can be written as 0.6 with the little dot above the first 6. It just shows that it's repeating. And we know that this is actually 2/3 of a whole. So we can write this as a simple fraction, 2 over 3, or 2/3. So it's a really good example of a repeating decimal that, no matter its size and repeating pattern, can be expressed as a simple fraction. So you can see that 2 over 3 is non-terminating, but it does repeat. So that is a rational number. I hope this has helped explain the difference between a rational number and an irrational number. Make sure you subscribe, hit that notification bell, and smash a like button to get notifications on future videos, and some of which will use these irrational numbers to solve many common mathematical problems. Thanks for watching. Catch you on the next one.